Hi, good morning to all my computer science friends. Here I am Victor Kai and my few other members gonna present a topic called database transaction and concurrency control. So why does it matter? Transactions are crucial for maintaining data integrity and ensuring that operations are completed successfully. Concurrency control is essential when multiple users access the same data, preventing conflicts that can lead to data inconsistency. Real-world examples such as e-commerce, order processing, and banking operations highlight the need for reliable system capable of handling concurrent interactions effectively, ensuring smooth and accurate transaction. And let's jump to what is database transaction. So what is database transaction? Database transaction is a transaction of operation executed as a single unit, like bank transfer between accounts. For example, to make sure that the data still stays after transaction. And now let's jump into ACID. So now let's understand what does ACID mean. So ACID is atomicity, consistency, isolation, and durability. So atomicity is all operations must succeed or fail together. Like example, performing both operations remain consistent. State if the transaction fail, they will not affect either account. Now let's jump into consistency. So consistency is the database transition from one valid state to another. Example, change affected data in correct ways. Now, let's jump into isolation. Isolation is a concurrent transaction that does not affect each other outcome. Like example, to reduce the number of users to access the same data at the same time. And last is the durability. Durability is committed change remain intact even after failures. So for example, like if we fail to send money to another account, that means the data will stay in our main account, the previous account.
Hi, I'm Yashin and now I'm talking about concurrency control techniques. So the first one is log-based. Log-based protocol control access to database resource, which preventing conflicts during simultaneous transaction. Then the next one is timestamp ordering, which ensure that transactions are executed in order of their timestamp, maintaining consistency. Then next one is MVCC, multi-version concurrency control, which allow multiple transaction versions and something with performance while preventing conflicts. Then the next one is lock, which is share lock and exclusive lock. A share lock allows multiple transactions to read data simultaneously without interfering with each other. And exclusive lock grants sole access for a transaction to read, preventing order from reading or writing. Then the next one is to understanding two-phase locking concept. So two-phase locking ensure transaction serializability by dividing the locking process into the two phases, accruing lock initially and release them afterwards, preventing conflicts.
Hi, my name is Jin. Today I'm going to be talking about concurrency necessity. Concurrency is essential as it enables multiple users to access and update the database simultaneously, enhancing system performance and resource utilizations. However, without proper management, concurrency can lead to conflicts and data inconsistency. Understanding the necessity of concurrency helps in appreciating the need for effective control mechanisms to maintain data integrity in real-time applications. Next one is concurrency problem. First one, loss update. A loss update occurs when one transaction overrides change made by another, leading to a data inconsistency. Second one, data read. Data read happens when a transaction read uncommitted change made by another transaction, risky incorrect data. Third, unreviewable read. An unreviewable read occurs when transactions receive data change before its completion, causing difference in result. Last one is phantom read. A phantom read happens when a new row are added or removed by another transaction before current transaction finish. Next is we need to understand the loss update problem. The loss update problem occurs when two transactions simultaneously update the same data item, resulting in one update overwriting the others and causing the data inconsistency.
Good morning and good afternoon, everyone. Today, I would like to talk about two key concepts in database transaction, that is insolution level and deadlocks. First, let's look at insolution levels, four close levels that govern how transactions interact. Read and committee lets transaction read and committee data, leading to dirty reads. Read committee only allow reading committee data but may cause not repeatable reads. Repeatable reads ensure a transaction see the same value throughout its duration and serializable. That higher level prevent all concurrency anomalies by isolating transaction completely. Next, deadlock. They happen when transactions wait endlessly for each other to release lock, grading operation to a half. Recognizing and mitigating deadlock is vital for keeping database efficient. In short, transaction guarantee database correctness via ACID properties, concurrency control, avoid conflict, and solution level balance performance and accuracy. Understanding these ideas key to maintaining data integrity in multi-user systems, and they are essential for real-world computing application. Thank you for watching.